Hi folks, it's me again. Today we're probably going to just do a quick video just to give you a little update from another little generator I'm putting together, but slightly bigger from the last one, since we had pretty good success with the first one with that tiny little guy. I don't know if you guys really remember that. So we're going to be, that thing was topping up at 10 amp at 26 volt and at constant run at 5 amp, 5.5 amp. It was no problem with that little thing. It was not barely, coming up to the normal working temperature. and that was the magnet was inside, because someone asked me also how do I remove the magnet from those little drum or any drum. You just use a heat gun and you just heat up the outside of the drum. If you heat up the outside of the drum, then you can, the glue is just it's almost like I think they use latex or enamel clear for gluing those magnets. So a little bit of heat, the magnet comes out easy. Putting them back together in the right selection, different tricks. It took me a little while, but it works out really well. So what I want to show you is I find out I had a fairly expensive filter queen sitting here, an air purifier which we're not using, and it was just sitting there, and it's machine is worth probably over $1,000, and I know it had a really quiet motor in there, so I just wanted to take a look how the motor was, and and obviously they look very normal motor and stuff like that, but one thing got very interesting is this one has got a stator. And it's got the anti-cogging system stator, but if you look at that stator and you know about Tesla, that is the first design he did when he did a 4-pole alternative current electric motor. This is the exact design of Tesla, and the only difference it is the legs, the length of the legs here, or I would say the end of the legs is got a long lip on it. That's the only difference from the Tesla, is that one here, they put that to get a release and a grab, and a release and a grab, which that's what I got very interesting about it, because now I can reduce my anti-cogging, because what I'm going to do now is to create and all the wire, for the first place, the wire is wind up left, right, and left again. And this is a generator they use as a motor, and what they had is a three-speed motor, so you had 4 different size wire wind up at the same time. So all I did is I took all the wire and cleaned it all up and solder it together, and then solder my connection to it, and so I got only 2 wire coming out. So it's going to be a high frequency, high voltage. I think we're probably going to push about between, I would say, 5 to 600 volt out of that at probably, I would say, 600 to 700 hertz if I turn that at 3600 RPM. Now the rotor have to be modified also. What I will do is I'm just going to take some 3/4 inch wide magnet, 1 inch long, North Pole, and I'm just going to get the machinist to just cut a channel, a square channel, so I can just drop the magnet in it, and the magnet will hold itself there. So that's most likely a very simple job. I'll take that to my machinist. That will get done, and then I'll go get those type of magnet. But that one is 1.5 inches long. I just need a 1 inch long and the same type of magnet, 1/4 inch thick. The neon magnet. And everybody says, "Oh, you're gonna have a lot of cogging." Yeah, you get a bit of cogging, but that's what the generator is all about. This is the starting, right? But soon you start moving this thing, the cogging goes away. That will be the same way, but the difference between that and that is my resistance. It will be a lot less since it's spin inside of the stator, right? It will be spinning inside the stator instead to be the magnet to be on the outside of the stator, and that way I require less torque for making the same motion with the same amount of resistance on it. I don't have to put so much torque into the shaft from the motor. So the motor I ordered are those wheelchair motor, those Chinese wheelchair motor. They're 500 watts, 24 volt, 4 brush DC motor. I've been working with those motors. I like it. They're quiet. They're quiet and they're really torquey, and they use very low, and you can spin those suckers really fast also. They have a very high speed. I think I cranked those one up to about 25,000 RPM just to see if they would, and that was just a 250 watt of output. So a lot of loose stuff, and also we're still working. We doing some progress on the controller also over there at the other lab we have in the States, and we have a lot of people contacting me over the email, and my suggestion for people is just wait a couple of more months and try to build stuff. Let's just wait a couple of more months. Watch the video, learn about it and stuff like that. Maybe if you want to build yourself a little unit like that little guy and stuff like this, try stuff small just to see, what I'm talking about. But we are very close to have something coming up. We'll be able to announce something. Say, here we got something, and it produced that much, and it will be ready, shortly. But we have the working prototype, and we can show you, make a video of it, and show you the working prototype. And then we can start, panicking and get the thing rolling faster and faster and faster. But right now we're just, for all the people from around the world. I mean, I'm just blowing me away how many people they email, and they've been working and learning about the stuff and saying the same thing. Man, is that you can literally multiply and it's a lot of people. They keep saying they want me to make that guy, the voting machine I call that one self-loop. Well, there's a lot of people, they already loop that, and it was not my intention to loop that up. It's, to me, it's just, it does what it does, right? But this one here, this guy here will be loop, because I can produce roughly around about, I would say, 20 amp at full, at constant run on that thing, and it won't damage it at all. So if I got 20 amp coming out of it, and I know it won't take me no more than about 5 amp to turn it, so I will be able to use at least 10 amp on the output as everything start working itself out. And of course, because I work with DC, I'm making high frequency AC. It's an AC signal, but it's high frequency. But this is like this is like a sine wave frequency generator. That's all it is. It's a sine wave frequency, high frequency generator. If you turn it really fast, it makes higher volt, higher frequency. But the way it's done, because of the magnet, there's no friction. It gave you it gave you a type of RF currents, which is totally different from the 120 volt we got from the plug here. It's a totally different current. It runs things much better. It's way less dangerous than the normal AC, which when you grab it, it will hold you. If you don't know what to expect, it will hold you and kill you. This thing, when you get a shock, it push you, and RF push you. It's got a pushing power for some reason. And every time you get a shock with all my high voltage stuff, it throws you away. Like it's like, don't touch me. So that's what was very interesting about the RF current. That's one of the big quality of the RF currents to me. Like it's that it's not a dangerous. I mean, it's still on a certain point dangerous, but not in the level we're working with, at the level of the 120 volt. It's just going to give you a slap, and then go away, and you won't get damage and stuff like this. So I mean, there's a lot of people that are working, and they all totally agree with me. I got even my friend there, Bob, my mathematician there. He finally agreed with me about the electron. Electrons do not move. I mean, it would be, if the electron would be moving, That's meaning they would go through you like BBs. Nobody would survive that. And at the speed they're moving. So it's impossible the electron move. But what I find out is the electron don't have to move. Like, you know, a wire, a piece of wire, right? A piece of wire is very simple. It's like a thread of electron full of, you know, all electron connected. So they don't have to move. All I have to do is send resonance, and the resonance will follow the will resonate inside the wire and will bring the resonance right to the end. That means everything we're looking is most likely solid. Like, you know, like when I have a piece of metal, again, it's a whole bunch of electrons compressed together. The purity, you know, they took all the garbage, and there's probably still some in it that's not totally pure, but you know, that's what we call steel, right? You know, same thing with those magnets we have. You know, we call them ceramic magnet, but it's like, you know, again, there's lots of iron in there. You know, I think it's like 85% iron. So I mean, like, you know, those magnets, they're just a big bunch of electrons compressed together, and they realign the field of the electrons. Now, if you align the field electron, now what's a field to me is like almost like a direction of all. It's just like making a fence pole, a pole fence, right? And you want to make your pole fence so it's all the poles that line up properly. So that gave me a feel of pole. I was just looking in my row of pole, and oh, nice. But if I don't put a line in the ground to put my pole like the same place, and they're all over the place, when you look at the end, it just looks like a zigzag. Well, now if I have to run along my fence now, right? If it's perfectly straight, I do a straight line when I run beside the fence. But if the fence goes like a snake in the field back and forth when I run to get to the end of that, and I'm running always constant along the fence, it's going to take me, you know, more time to get to the end, because my fence is no longer, and I have all those obstacles to go around. And that's what, you know, electron will produce in the wires. They gave a gateway for the resonance. You know, they literally gave a gateway to resonance to flow through it. Now, copper is just like the bent fence. Now, if you use aluminum nickel, because how the element of the nickel is and how the shape of the electron of aluminum is linear. It's not all over the place. They have a perfect linear electrons. So when you're shooting, you know, a resonance into a wires which is made of aluminum, then that fence is perfectly straight, and that just shoot right out. There's no zigzagging to get to the end of it. So I mean, like, you know, it's kind of a crude explanation, but you know, it's pretty much what's happening on a wire. The wire is the electrons. Everything you work, all the solid stuff is all that's electron. Electron like to create mass. I mean, like, you know, for example, if you over resonate a cable, an iron cable, if you over resonate an iron cable, what happened? It vaporizes. That means now you resonate everything up, and all the electrons that were bound together just went poof, all apart. That's why we see power line vaporizing. It goes just, you see it goes red, and then it goes poof, it's a puff of smoke, and the line has disappeared. I mean, like, you know, I can watch a dozen videos of incident and big power line and transmission, and they all disappear in dust. So all those electrons, the bonding of those electrons, they just let go, because there was way too much force of resonance into that wire, and that's what I call pressure. So, but anyway, I won't make this video very long. So, yeah, keep checking out, because soon I get all the parts. I'm going to be spinning that. I think my 2 motors are coming in, I think by the end of next week. So I should be able to start putting things together, you know, fairly quickly, to do a test run with that and see how much volt. And when I got that, then I will show you exactly. Before it's all looped up, I'm probably going to make another video. That's how much is used, that's how much I put out, that's how much load I can put in, just like I did with this little guy. And then from there, I'm going to move on to looping the whole thing up so you run by itself, and hopefully I won't have to use the batteries. I will have power up batteries for starting it, and then, but I'll be able to disconnect my batteries after I'm done. I'll be using Maxwell cap or super caps anyway, so to do it. So that's about it for now, and I guess we'll catch you next time, and hopefully we'll have some good news on the progress on the controller and on this one here. All right, folks, you guys have a good day, and we'll talk to you later.